Okay, in our last lecture, we have introduced Timsort and given a rough idea of how we can write the Timsort using the two well-known algorithm, merge sort and insertion sort. So today we will see how each step of Timsort works. Okay. So in Timsort algorithm, the first thing was given a long sequence of array, break it into chunks, and the chunk size was fixed. There was some constant called minimum run length. Generally it is taken 32 to 64, but I have taken a small example, so I have fixed this minimum run length equal to 5. Okay, let's say this is my array of elements, and we have to run decomposition. Okay, how we will create the small runs, and what are the issues involved when we will go for the break the inside into the run, and what will be the complexity of the run decomposition. Okay, so let's say this is my array of elements. There are many elements, and there are 3, 5, 2. Okay, 3, 5 is increasing, then 2 is decreasing, then 7, 9, 11, 13, 17, all are increasing, then 5, okay, then 2, 2, 2, 2, 2, 2. This is neither increasing nor decreasing. Okay, so how to handle this issue also, and then 1, 0, 0, 7. Okay, I have included repetition of number. Now, how to write an algorithm which will decompose this into small size of runs. Minimum length will be 5. So how we'll do this? Obviously, we have to read all the elements. If we want to decompose this, we have to read all the elements. So if we are reading all the elements, the complexity cannot be less than order of n. Okay. Now, in order of n, we can write algorithm in many ways. One of the most suitable way is identify the peak and valley. Okay, so I am introducing two more concepts. One is peak. Okay, peak and valley. So what is peak? For example, 2, 3, 5, 2, 7, 9, 11, 13, 17, 5. Okay, here 17 is the peak. Okay. So what is the definition of peak? Definition of peak is when the previous element is smaller and the next element is also smaller. So a point xi or xk is peak if xk minus 1 less than equal to xk less than xk plus 1. Okay, so I have written this. Now there is many confusion in many versions where to take the equal to. Should we include equal to, or it should be strictly less? Okay. Now for the time being, let's omit the equality. Okay. Now it looks like a perfect peak and it satisfies the definition of everything. So now after 17, 5, 2, 2, 2, 2, 2, then 1, 0, 0. Okay. It's look fine. Let's define the value in the similar way. Okay. X k minus 1. Okay. This greater than equal to xk and greater than xk plus 1. So we will see whether we need the equal to or we don't need equal to. Okay, and if we need equal to, whether it is in the previous element or the next element, that we can check. How? So let's say now we got the definition of peak and valley. So what to do to find a run? What is the definition of run? Run is all about peak to valley. On any peak to next valley is a run. Reverse is also a running. Valley to peak is also a run. So there will be two type of sorted array, sorted run. Okay. One is if we go for peak to valley, it will be an increasing sorted run or decreasing. It will be a decreasing sorted run. So it is decreasing. If we go from valley to peak, we will get a increasing run. Okay, we will get a increasing run. So we will have increasing run and decreasing run. How to do handle this decreasing run? When we take the march function, how march function one? March function takes input to sorted array and return a sorted array. Okay, but it is this return item is merging to of the both the element. Okay, so both are sorted. Input elements are sorted. Output elements are sorted. Okay, so now in case of decreasing sequence, we don't have the input arrays sorted. So we need to perform one more step. That is the we have to reverse the string. Okay, so reverse. So what will be the issue if we go to for a reverse? Suppose I have the element like from 5 to 1 0 0. This is a run. Okay. This is a run from here to here, and I have to run a reverse. So generally, reverse algorithm, the good reverse algorithm, what is to is get direct swap between the first element and last. Okay. Then next element with next element. Okay. That is in our first year we have written the code and reverse the element. Now what we will do if there are all the element with same number, let's say 55555 every place. So how the reverse element will work? Reverse element reverse function will work unnecessarily because all the element are same. So that will create confusion in the reverse function and the decreasing element. Actually, we don't need to do anything. So a better way to handle this situation is don't keep the same element thing inside the decreasing sequence. Okay. So if we want to keep all these things in the increasing sequence only, same element inside the increasing sequence, not in the decreasing sequence, then we can modify this definition like this. This thing is called a play to. We are calling peak value, then this 2222 can be called as a play to. And this play to should be included inside the increasing sequence, not in the decreasing sequence. Okay. So if we maintain this definition of peak, then peak will include all the equal elements in the increasing sequence. Now, how to change the definition of valley also? So, what will be the definition of valley? 17 is as per my definition, xk minus 1 greater than equal to xk. So, 17 is greater than equal to 5. It is going towards valley, and then it is also greater than equal to 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 Okay, so the definition of valley should also be changed. Okay, what should be the definition of valley? Because it is a decreasing sequence. If we stop the valley here, then we will get the increasing sequence later. Okay, it will be included in the, so definition of valley should be here. So in valley we will prove this inside xk minus 1 greater than equal to xk. Okay, xk is a valley in xk greater than equal to xk strictly less. Oh, it was right. Okay, xk minus 1 is greater than equal to xk, that is fine, and xk plus 1 should be strictly greater. So there is 2, so it is this value or not? This is value or not? 2 is the value, this is equal, and that is not satisfying, so it will cut here. Okay, so we have to change the definition. What to do? 17.5 to, okay, uh, you can check it where to put. I think this will work. Okay, the definition of value will be this. Now anyway, once we have peak and valley, and valley and peak, we have increasing sequence and decreasing sequence. Inside decreasing sequence we have to go for a string reverse. String reverse, and then we have the run. Now if the length of this increasing sequence or decreasing sequence is less than 5, for example in the first place 352, okay, 3 5 is increasing sequence, but 2 is smaller number, so there are only 2 elements, and after the 2, 7 9 5 13 17, okay, this is a run. Okay, so we will take up to this, there are 2 elements which is unsorted, because we have to take more than 5. Okay, so there are 2 elements unsorted, so we will have the first run will be 3 5 2, because if the 5 element comes up to this and run is continuing, we will include the whole 2 7 9 11 13 17. Okay, so now we will have insertion sort for this. Okay, if we run insertion sort, first element 3 is fine, then next element 5, previous element is smaller, is fine. Now at 2, the previous element is 5, then previous most element is 3, so 2 will be removed from here, and 5 will be shifted here, 3 will be shifted here, 2 will be put here. Okay, now for 7 9 all the previous element, so there is 2 comparison, for one element we have to fix, and we got a sorted sequence. That is the beauty of the Timsort, using including why it has included the insertion sort, because we have to take the advantage of already sorted sequence. Okay, so that is run decomposition, the first step of the Timsort. In next lecture we will see how the run stack work, and then how merge collapse work, and we will see one more most important concept called galloping. Okay, galloping in the merge function. So meet in the next video.